Well, hello again. Mrs. Saunders here. Today we're talking about two-dimensional figures. And our learning objectives, I would like you to introduce yourself to a few polygons and learn how to get around them. So I've got one more example of when vocabulary didn't quite work, when somebody didn't quite know what they were saying. All right, no celery phones. Does that mean literally like you can't have celery on a phone? Or does that mean like cell phones can't be with celery? I have no idea. But anyway, again, it's important to know the vocabulary so that we're on the same page. Polygon. Polygon is a closed figure formed by a finite number of sides. Finite means you can count them. You have the ability to count each of the sides, which is opposite of infinite or infinite. So finite number of sides, and each side intersects exactly two other sides. So this is a polygon. And we've got a bunch of sides. This is side CB, and this is vertex A. We've got all these other vertices as well, E, D, C, B, A. So here's a bunch of polygons. All these guys here are polygons. So it's a finite number of sides. I can count them. There's vertices, and each vertice has exactly two sides. Some non-polygons, these are all non-polygons, because like this one has a big gap here. It doesn't close. This one doesn't have, it doesn't close there. And there's this intersection. Circles, ovals, those aren't considered polygons. So just kind of look at those back and forth and make sure you kind of get an idea of what a polygon is. Concave. Concave means that a certain polygon has a dent or a cave, like this guy. It's got a dent. It's kind of caved in right there. Convex is the opposite. It doesn't have a dent or a cave. See that one? No dent. A polygon is classified by its number of sides. So 3 sides is a triangle, 4 sides is a quadrilateral, then a pentagon, hexagon, heptagon. Yes, you need to know all these. Octagon, nonagon, 10 is a decagon, 11 is an undecagon, 12 is a dodecagon. Okay, so then they got tired and they were like, we're done with the special names. Now we're just going with n is an n-gon, meaning like this guy has 15 sides, so we'd call him 15-gon. It's kind of silly, I know. Okay, an equilateral polygon means that all the sides are congruent. So I could put congruent markings on each of those sides. That means equilateral. Lat means side. An equiangular polygon, look at this, angular, means that all of the angles are congruent. So I could put these little congruent markings on each of the angles. That's an equiangular polygon. A regular polygon is when it's equilateral and equiangular. So all the sides are the same and all the angles are the same. So let's look at some examples. This guy we did earlier, this one's equilateral. All the sides are the same. This one was equiangular. And this is a regular polygon. All the sides are the same and all the angles are exactly the same. So these 3 on the bottom are regular polygons. Well, that looks kind of funny how I did that, but hopefully you get the picture. So we're going to do some practice. Name the polygon by its number of sides and then classify it as convex or concave and regular or irregular. First one, this guy. Okay, number of sides is 4, so that's a quadrilateral. Convex or concave, it's not caved in, it doesn't have a dent anywhere, so that's convex. Regular or irregular. This one's irregular because, see, this side and this side are not the same. All of the sides have to be exactly the same for it to be a regular polygon. Okay, what about this one? It's got 1, 2, 3, 4, 5 sides, so that's a pentagon. It's got a big old dent right here. It's caved in, so that's concave. and it's super irregular. It's all kinds of wonky. And then this last one, what do you think? It's got 6 sides, so that's a hexagon. All the sides are the same, all the angles are the same, there's no dents, there's no caves, so we've got a convex regular polygon. Now we're going to move on to perimeter and area. So the perimeter of a polygon is the sum of the lengths of all the sides of the polygon. It's the distance around the polygon. The area of a figure is the number of square units needed to cover a surface. It's the inside. So again, the perimeter is the distance around, the area is the stuff inside. So we're going to start by talking about a triangle, and I can name the sides of the triangle BCD, and then I'm going to draw this other line here called the height. So in order to know the height of a triangle, we have to have a line that comes from a vertex and hits at a right angle. That's how they measure height. So C cannot be the height of a triangle because it doesn't hit the ground here at a right angle. So the perimeter is the distance around, and so the perimeter is just adding the sides together, B plus C plus D. And the area, the formula for the area of a triangle is 1/2 base times height. So we'll practice with this one. The perimeter is just adding all the sides. So 3.5 plus 2.5 plus 3, it's 9 centimeters to go around it. And then inside, we're going to use 1/2 base times height. So the base is here, 3.5. And again, here's the height. It comes straight down and hits at a right angle. That's what makes it the height. So multiply all that together and we get 3.5 centimeters squared. So it's squared because, you know, we've gone into two different dimensions. We've got base and height. Okay, a square, if the side is S, then the perimeter is S plus S plus S plus S, because all the sides are the same. So if you want to shortcut that, it would be 4S. The area of a square is side times side, or side squared. So if we practice with this one, the perimeter is going to be 4 14s. 14 plus 14 plus 14 plus 14, or 4 times 14, which is 56. And then inside, it's going to be 14 squared, which is 196 yards squared. Now a rectangle is defined by, let's see, length times width. And the length and width are this, whoa, that looks terrible. The length and the width are the same on both sides. So that means over here is a really wonky W, and up here is another L. So the perimeter is going to be length plus length, and then width plus width. Or you could say 2 lengths plus 2 widths, okay? And then the area is just length times width. So we're going to practice this with this one. We've got 3 is the width, 9 is the length. So 2 lengths plus 2 widths is 24 inches. And then the area, 9 times 3, 27 inches squared. All right, now a circle is not a polygon, remember? But we're still going to talk about it. Instead of calling it a perimeter, the distance around we called the circumference. It gets its own name. And then the area is still the stuff inside. Now, before we find the circumference of a circle, we need to know 2 other things. The distance across the circle, this guy all the way through the middle, is called the diameter. And then just from the middle to the edge is a radius, okay? You can have a lot of radii in the circle. They're all over the place. So the circumference, or the distance around, is 2 pi r. Remember, pi is 3.14. It's a number. Actually, it goes on for a long time, 3.14159, blah, 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 blah. But for our purposes, we can just stop at 3.14, or we can say pi times the diameter, because actually 2 radiuses is the same thing as 1 diameter. And the area of a circle is pi r squared. That's the formula for the area. So here's a circle. It's got a radius of 4. So the perimeter is 2 pi r, 2 times pi times 4, which is 25.12 feet. And the area is pi r squared, so 16 pi, or 50.24 feet squared. Now this is what we call coordinate geometry, meaning we take what we know, what we've learned about geometry, and we're going to translate it onto a coordinate grid. So for this it says find the perimeter and the area of this triangle DEF with these vertices -2, 2, 1, 5 up here, and 4, -2. Now in order to find the perimeter, we need to know the length of each of the sides. And when we're on a coordinate plane and we're not given the length of each side, we can find it using the ever popular distance formula. Remember that? So DE, find the distance formula using that. We've got the x2 minus x1 squared plus -2 minus 5 squared. So we'll work on that. -2 minus 1 is -3. -2 minus 5 is -7. So we have the square root of 9 plus 49. So that equals about 7.62. So that was DE. We made 7.62. And EF actually turns out to be the same, but let's go ahead and see what it looks like. We've got 4 minus 1. Let's just see where this is over here. 4 minus 1 and -2 minus 5. So when we do the math on that, we get 3 squared and then -7 squared. Look, it's the same thing. Square root of 9 plus 49, which is 7.62. Now DF, this is awesome. We can just count 1, 2, 3, 4, 5, 6. I love it when it's a straight line. We don't even have to do the distance formula. It's just 6. Okay, so now that we know the length of each side, now we can find the perimeter. So the perimeter is just going to be adding those sides together, 21.24. And then the area is 1/2 base times height. So we know the base, the height we're going to have to count. So 1, 2, 3, 4, 5, 6, 7. The height is 7. Now we just plug it into our formula. 1/2, 6 times 7, which is 21. That's coordinate geometry. If you just take it one step at a time, it's not as bad as it looks. So again, thanks for being here, and I'll see you next time.